Lesson 3.7, Graphing in Context. By the end of this lesson, you'll be able to identify the slope, y-intercept, and x-intercept in a real-world scenario, graph a real-world linear function, and describe the slope and y-intercept and x-intercept in a real-world context. Let's look first at just review about the parts of a graph. So we got a lot of things that are on a graph that we make sure we need to identify or find to help us know what that graph is talking about. Well, the first thing is, of course, knowing what the title is. That tells you at least what this graph is describing. The graph, of course, is the line that's on the coordinate grid or the coordinate plane. Then, of course, you have your y values and your x values. Then, of course, on the y values, you have your units for y. And over here, you have your units for x. Always double check what they're counting by when you're trying to find slope or rate of change. So we can see for this one, we're counting by tens on the y's. For the x's, we're counting by 1. It's always good to know because they will change that on you. Let's look at our first example. Howard decides to start jogging every day at the track. The first week, he jogs 5 laps. He adds 3 laps each week for 8 weeks. Let L represent the number of laps Howard runs, and let T represent the time in weeks since he began jogging. What they first want us to do is create a table. So let me get my pen marker here, and let's create a table. So they tell us what those values are. So let me go ahead and highlight some key things. So first off, the first week, 5 laps. Then he adds 3 laps each week till 8 weeks. L represents the number of laps. T represents the time in weeks since he began jogging. So we're going to draw a little table here. We're going to make a vertical table. So since time is always your x-axis, so we're going to have time right here. So T, which is our weeks. Draw my little line. My graph seems to want to smush in the middle of my table. And then of course L represents our laps jogged. So first off, the first week, how many laps did he jog? Well, that was they gave that to us. His first week, he jogged 5 laps. Then he adds 3 laps each week. So then just add 3 to 1 to get 4. Yeah, okay, well, let's actually put that down by below, because in week 2, there we go, we had 3 to 5 and get 8. Then week 3, and let's just get all the weeks out here, because I've already made a boo-boo now. So let's just get these weeks out here. We're going all the way to week what? Oh, that's right, 8, because they told us week 8. And then this chain's always got to be 3, because that's what they're doing. That's the rate of change, really, right there, which is actually hitting toward another answer here, but we're going to keep going. So add 3 to 8, we get 11. Add 3, 14. Add 3, 17. Add 3, 20. Add 3, 23. Add 3, 27. I can't count. That's 26. There we go. That's better. There's our table. Now what they want us to do next is plot the ordered pairs and connect the points by drawing a line. So here we have a coordinate grid. Now we got to look to see. Well, definitely on our x-axis, which would be our time, we're going to want to count by 1s and go all the way to 8. So let's do that here. That'll be 1, 2, 3, 4, 5, 6, 7, 8. We might have been able to go each and every one. I don't know. Let's see. 1, 2, 3, 4, 5, 6, 7. Yeah, we could. Actually, let's do that. Let's do every other one would be 1. That way our graph looks a little bit better. So this, of course, is 0. So 1, 2, 3, 4, 5, 6, 7, 8. And this, of course, is weeks. Make sure you label when you're making a graph. Then we got to look at our y variables. We start at 5 at 1 week. And then we are looking at going up. And we go pretty high. So it looks like we're going the highest is 26. So we got to make sure we include that point on our graph. So then I got to see, what can I count by? Can I count by 2s? Let's see. Let's do this each line. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6. We can do 26. So I think we should count by 2s. And every unit is a 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and then we'll stop at 30. And this, of course, is our laps. Now we can go ahead and plot our points. Our first one was first week. We had 5, so it's between 4 and 6. Second week, and I got to go back, we had, what was it, 8? And then we're going up 3 by then. So then 3rd week, we had 11. Then 4th week, we had 14. Then 5th week, we had 17. Then 6th week, we had 20. Then 23. And then 26. Then we can now draw a line by connecting the points. And then now we're able to actually answer some more questions. Now we got the line graph. We're looking at C. What was Howard's rate of change? Well, they actually give it to us in the problem when they said he adds 3 laps each week. But we also could find it on our graph if need be. So if I go up, I'm going to go up 1, 2, 3, because remember we're counting by 2s here. So we go there, and I'm going over 1 week. So it's 3 over 1. So then my rate of change, of course, is 3 to 1. Or what we could do is just use 2 points here and just take the first 2 points. So we can actually take those 2 points, 2, 8. So second week we had 8 laps. First week had 5 laps. We can actually do the slope formula, which is our rate of change. So 8 minus 5 over 2 minus 1 gives us that 3 to 1, which is what we had right here when he tells us we're adding that each week. So then what's his rate of change? Well, it's 3 laps per week. Don't forget units. What does that mean in context? Well, this is what it means in context. And I'm going to write a nice good sentence here using, of course, my typing mechanisms here. So what it means in context, it means, so we can say that on average, Howard runs 3 laps per week. That's all you got to do. Just put the rate of change in words in regarding to, of course, here, and it's actually not run. He actually jogs, so we probably should change that. That'll be making more better. Jogs. There we go. 3 laps per week. Or he increases his laps per week by 3. A lot of different ways you can interpret that context. Let's look at our next example. Here, the graph below represents the weight loss of a wrestler as he prepares for a state meet. So, they want us to first calculate the slope and what does it represent. So again, we got to calculate it and then write it in words. Well, we have values here. We can just go ahead and do it. Just pick any 2 points. I'm going to take these points. So it looks like, well, that was weird. I'm going down 1 pound here, because remember, I got to look at my units to know what I'm going down. I'm going down 1, and I'm going over 1. So it looks like our slope is 1 over 1, which in turn means 1, but we also got to put it in words. It's 1 pound per week. So we can say that the wrestler loses 1 pound per week. And let me just write that in there because also that's a pretty good place to say. So let's say the wrestler loses 1 pound per week. Then he wants to identify the y-intercept and what does it represent? Well, the y-intercept, of course, is where it crosses the y-axis. So that is simply just this value right here. It's also known as your starting value or your starting point or starting height or whatever. Here, of course, we're looking at weight. So at 0 weeks, which means the start, he is what? 190 pounds. So all we have to do now is just interpret that. So first identify it. It's 0, 190. And then talk about it, about what the 0 means and what the 190 means. So we can say 0 weeks in 0 weeks, or to say at the start, the wrestler weighed 190 pounds. There you go. Easy peasy, wobbin' easy. Let's move on. Number 3. Here, the cost of a long-distance telephone call is 50 cents for the first minute and 10 cents for each additional minute. So this is really good to know. Some good information right here. So first 50 cents for 1 minute. So that's just automatically there. And then each minute after that, it's 10 cents. They want us to let C be the total cost and T be the minutes. So again, our time. First off, we got to make a table. So let's do that. Okay, we're going to make a vertical or horizontal, horizontal table. This, of course, be our t is time because that's our x. And then our other one will be, of course, cost, which they want us to use c. And then we're just going to get some values. They want us to go from 1 to 10 for time. So let's go 1 minute, 2 minutes, 3 minutes, 4 minutes, 5, 6, 7, 8. I got to make this a little bit longer. 9 and 10. We can do that. It's not an issue. We just draw a little more extra boxes here. And then, of course, separate them. Now, so for the first minute, we know how much it costs. For the first minute, it costs what? 50 cents. That is what we are starting out at. So 0.50. 0.50. And then for each additional minute, we're just adding 10 cents. So add 10 cents to 50 cents, and we get 60 cents. Add 10 cents, 70 cents. Add 10 cents, 80 cents. And so forth and so on until we get to our 10-minute mark, which looks like it'll be $1.40. Now we want to find the, and I want us to make a graph. Oops, I didn't see that part. Make a graph. So let's make a graph here. So again, we know what we should count by on our x-axis. Well, because we're going by ones, so let's go by ones. I think I'm going to skip every unit square to make it look a little bit more neater. So we're going to go, this is 0 minutes, 1, 2, 3, 4, 5, 6, 7. Oh, I can't do it. So nope, we can't do that. We're going to have to count by ones the other way. Because remember, we got to put all those data in there, because that's what they're asking for. So I guess we got to go each unit, which is fine. So we'll just write it out. Choo-choo! This is our time, and it's in, of course, minutes. Then we got to get our costs of how much it costs. So it looks like we start at 50 cents and we're going up by 10 cents. We got to get to $1.40. So let's count and see what we have here. Maybe we can count by 10 cents on each one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we can definitely count by 10 cents because we'll get to 14 easily. So let's count by 10 cents on each one. This is the tedious process of this graphing. So hopefully you're doing it quicker than me, or maybe you're doing it with me, or hopefully you're already have done it. I don't know. Okay, my numbers are getting a little squished, but I can see where they're going. Hopefully yours look a little better. There we go. We got to $1.40. I think we can stop. I'm going to go to $1.50 just because I want it. So remember, this was our cost. Now he's got to plot points. So for 1, it was 50 cents, 2, 60, 3, 70, and then so forth and so on, increasing by 10 cents. There we go. And to get to that, then we just, of course, draw our line. And we have our beautiful graph. Now, they want us to know the average rate of change. Well, again, they gave that to us in a problem. If we looked at it, that was that 10 cents for each additional minute. You can, of course, find the slope and do it that way, plug in points, you got a table, but really it's that right there. So what's the average rate of change? Well, for every minute, the cost increases by 10 cents. There you go, Tony. By 10 cents. What does the y-intercept represent here? Well, here it's a little bit misconstrued, but I mean, we can get an idea. I mean, should be that if I don't talk on the phone, it costs 0. But generally, if we draw our graph and draw our line like we did, this is actually our y-intercept right here. So technically, it would be 0, 0.40. And technically, I mean, this is horrible. And maybe there's some phone companies that actually do this. I don't know. Man, that'd be awful. But actually, this would actually represent that for a 0-minute phone call. And this is actually, I think, long distance, isn't it? Yeah, it's long distance. So actually, for a 0-minute long distance phone call, it costs 40 cents. That means it costs just 40 cents just to pick up the phone. Sounds weird, but according to our graph, that's what we have. Okay, I'll probably be fine if you said that 0 minutes it costs $0, which it should be true, but of course our graph is like this. So moving on now. Next one, number 4, Steve is going to a vacation to Flagstaff. He made some calculations during his trip to Flagstaff and record them in the table below. They want us to first create a table for Steve's data. Okay, well, we got points here, so let's just go ahead. This is my time in hours. We're going from 0, 1, 2, 3, and I don't think we need it, but we only go up to 2. And then it looks like we're counting by 60, so let's count by 60 here. 0, 60, 1, 20. Then, of course, plot our points at 0, 0, 160, and, of course, 220. And then we got, our course, our nice, beautiful line on that. Once I figure out how to get my line here, there we go. Bam, there we go. Then, of course, they have us some questions that we got to answer, which I'll do, of course, in text. What does the y-intercept represent in context? Well, here the y-intercept is, and I got to go back over here, shoot, my bad, is right here. It also looks like it's our y and our x-intercept, so we'll be able to answer B and C here, which is really nice. And so, but what does it represent in context? Well, we know it's 0, 0. We just got to, of course, write it in words. Well, what does the x represent? Time. So we can say in 0 hours, or really at the start of his trip, you could say, he has traveled, or Steve has traveled 0 miles. Or we also could say that Steve is at home, because it's the distance from home in miles. So, yeah, and I forgot to put my miles over here on my axis. I don't want to do that, huh? So let's actually do that before I forget. Mile. Oh, God. Here we go. Miles. Oh, my God. Yeah, that's miles. Okay. Also, since the x-intercept is also the y-intercept here, which is kind of nice, so we actually can express it again. So here we can say that this x represents that, well, at 0 hours, let's do that one. At 0 hours, sounds like we're military, Steve is 0 miles from home. I'll move that up so we can see that better, but there you go. And then what does the domain represent in this? This is a good question, definitely a test question. I think this whole thing is actually a test question. But domain is, of course, our x values. Well, what's our x values here? Their time. So what does our domain represent? Well, simply our domain. The domain represents the time it takes for Steve, let's capitalize his name, to get to Flagstaff. There we go. All right, next one. All right, this one I'm going to pause the video, or tell you to pause the video. You can calculate the average rate of change here, and then you can compare it from a different average rate of change, because we've done this before, so I'm going to have you go ahead and pause this video and try this out. So pause this video, please. Thank you. So here we calculate the average rate of change from home runs hit from 1990 to 1992. Got negative 139.5 home runs per year. So it looks like they went down during those 2 years. And then we compare the rate of change from part A to, of course, now finding a rate of change of 1995 to 1996, which we got 181 home runs per year. So here they increased. So then we can just say, by comparing, that there was an increase of 181 home runs from 1995 to 1996, while there was a decrease of 139.5 home runs from 1990 to 1992, probably because there was more steroids used. Okay, well, here's your chance now to shine. Go ahead and try the perfect practice out.